Now look at the statement. What is the statement? Calculate branch voltage and branch currents. Actually, branch voltages and branch currents for the network shown below using Tyset approach. This here, in this case, we are preparing or we are using the Tyset approach in this particular case. We are using the Tyset approach in this particular case for the calculation of the voltages and current in this case. Is it right? Now look at how will be the approach. This is the given figure. This is the given figure. But what is the requirement in this particular case? What is the requirement in this particular case? I will go back. I will show the requirement. I will show the requirement. Each branch of the network must be in the standard format. There should not be any current source. Is it right? If there is a current source, convert that current source into the voltage source. That is the requirement in this particular method or whatever the method I am suggesting to you. Is it right? Here in this particular case, already this should be the impedance, and here should be the voltage source. Already our figure is in the standard format. That's why I will not use anything. I will take one problem in which the figure may not be in the standard format, and I will discuss how to convert it to the standard format. Yeah. Now, first we will mark the nodes. How many nodes we have for this figure? I have marked it here. This is one node, this is the second node, this is the third node, and this is the fourth node. We have the 4 nodes. Is it right? At the same time, our interest is to prepare the oriented graph. Our interest is to prepare the oriented graph. For the preparation of the oriented graph, what we have done here, I have taken the direction in each branch. I have given the name to this branch as branch number 1, name to this branch is the branch number 2, name to this branch is the branch number 3. It is 4, 5, and 6. This is branch number 1, this is the branch number 2, this is the branch number 2, this is the branch number 3, it is the branch number 4, this is the branch number 5, and finally, this is the branch number 6. At the same time, I have taken some direction for each current. Choose any random direction. I have taken this is forward, this is downward, again, this is downward, I have taken this is downward, and this is backward. You can assume any direction in this particular case. You can assume these directions are, this current may be something like this may be the upward, 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 and this may be the backward. This may be the assumption from your side. But whenever you will assume the directions of the current, stick to those directions. Is it right? Whenever you are assuming the directions of the current, stick to those directions. We are not going to change the directions. Is it right? We are not going to change those directions. I have taken these directions. Now here, based on these assumptions, I will prepare this oriented graph. Here I will name this node as node A, this will be the node B, this will be the node C, and then this is voltage source should be replaced by its internal instance, which is 0. This complete branch will be replaced by one line. This is second branch is second line, third branch is third line, and so on. Its direction is upward, that's why this branch direction is upward. This may be the downward, this may be the downward, again this is backward, and this is backward, and this is again something like this. Means here in this case we have prepared this matrix, this graph, which is nothing but the oriented graph. First step in the calculation of the branch voltages and branch currents by using this method or Tyset approach is nothing but first prepare the oriented graph. Is it right? I will go step by step. How is the step? Now look at. Just here I am reading the procedure. What is the first procedure? Draw the oriented graph. We have drawn. Now select the tree and prepare the Tyset matrix. Here, if I am coming down, now this is the graph for this is given network, and this is oriented graph which we have prepared. And for this prepared graph, select any one tree. This here, if your tree is different, your solution will be the different. Your answer will be the different, right? In this case, I have selected this as a tree. What is the standard definition of the tree? What is the definition of the tree? Tree is the set of branches. It will connect all the nodes to each other directly or indirectly without forming the loop. Now here, this may be the one branch, this may be the second branch, and this may be the third branch, this may be the tree. Is it right? This may be the tree. This is maybe downward, this is again downward, this is again downward. But here, in place of the symbol, I have taken this as a tree. If you have taken this as a tree, then your calculations will be as per this tree. If I have taken this as a tree, then my calculation will be as per this tree. But your final branch currents and branch voltages, there is I1, I2, I3 and V1, V2, V3 will be the same, use any method or any approach. Branch currents will be the same. Is it right? So here in this case, I have selected this as a tree. This is the node A. This is the node A. This is the node B and this is the node C. Now here, I have taken this branch 1, branch 2 and branch 3 and this is my tree. What is a tree? It is a set of the branches which connects all the nodes to each other without forming the loop. There is no formation of the loop. This is the tree. If we have the tree with us, then first prepare the tie sets and then prepare the tie set matrix. How are the tie sets? I will discuss the tie sets. How are the tie sets? Now here, 1, 2, 3. This is branch number 1, branch number 2, and branch number 3. These 3 branches I have taken as a tree branch. Means the branch number 4, branch number 5, and branch number 6. These are the co-tree branches. How many co-tree branches we have here? We have 3 co-tree branches. Put 1 co-tree branch at a time and prepare a loop or form the loop, and that loop is nothing but the tie set. If I am putting this branch number 3 here. If I am putting the branch number 3 here, now in this case, this is branch number 1, branch number 2, and this branch, which is branch number 4, that is nothing but 1, 2, 4. Means branch number 1, 2, 4, it will form a set, and this set is nothing but the tie set number 1. Is it right? Similarly, this is our tree 1, 2, 3. This already I have discussed. If we are putting this branch, something like this, this is the formation of loop, and this is known as the tie set number 2. How is the current for this tie set? The direction of the current of this tie set is the same as the direction of this co-tree branch. Co-tree branch current is downward. If this current is downward, in that case, its direction will be something like this. That is the branch of current of this particular loop. Is it right? And finally, if we are putting this branch number 6, which is the co-tree branch, something like this, and its direction is forward, in this particular case, it will form the closed loop, and this closing loop is nothing but the tie set number 3, and its direction will be the clockwise, branch number 1, branch number 2, and branch number 3, but the loop direction will be same as this tie set direction in that case. Now, that I have tried to show here. This is our selected tree. For this tree, this is the tie set number 1. Look at this branch I am putting here, branch number 4. In that case, it will form the loop, and this tie set number 1 is 1, 2, 4 is the tie set number 1. In that case, how is the direction of this tie set current? Direction of this tie set current is the clockwise, because this direction suits to that direction. Tie set number 2. If we are putting this branch, which is the branch number 5, co-tree branch, that is the branch number 5, in that particular case, we will get this closed path. This closed path. And the direction of current in this particular loop will be something like this, because it is same as this current, which is suiting to that current, is nothing but it is anti-clockwise. And finally, if we are putting this branch here, in that case, again, it will form this as closed path. Closed path is nothing but loop. Closed path is nothing but the tie set. This tie set concept is very same as the loop concept. Now, this will form the closed loop. Branch number 1, branch number 3, and branch number 6. How is the direction of the current? Direction of the current is very same as the direction of this co-tree branch, which is branch number 6. It is same as this, which is clockwise again. This first current is clockwise, second is clockwise, anti-clockwise, and the third is again clockwise. Which what we have done, we have prepared the oriented graph. We have selected a tree. For a tree, we have prepared the 3 tie sets. Tie set number 1 for 1 co-tree branch, this is for second co-tree branch, and this is for third co-tree branch. And if we know the tie sets, prepare the tie set matrix. Prepare the tie set matrix. Now look at how will be the tie set matrix in this particular case. Here, this rows of this matrix are tie set. This is tie set number 1 is the first row. Tie set number 2 is the second row, and tie set number 3 is the third row. Is it right? Then column of this matrix are the branches. Means this is the branch number 1, this is branch number 2, this is the branch number 3, this is the branch number 4, here is the branch number 5, and finally it is the branch number 6. I will go with the tie set number 1. Tie set number 1 means this loop number 1. In this loop 1, this is one branch, its direction is same as this direction. Same as this direction of this loop current or this tight current. That's why its entry is plus 1. This is right. Similarly, for the branch number 2, this entry and this entry is the same. That's why its entry again plus 2. For branch number 4, again this direction and this direction is same. That's why its entry is again plus 4. But for branch number 3, branch number 4 and branch number 6. This is the branch number 4, branch number 356. Branch number 356 is not the part of this loop. Branch number 356 is not the part of the loop. That's why its entries are 0. If I'm coming to the loop number 2 or tie set number 2, for the tie set number 2, this current is anti-clockwise. This direction and this direction is suiting to each other. That's why for the branch number 2, its entry will be plus 1. For the branch number 2, its entry will be plus 1. Similarly, for the branch number 3, look at this is downward. This is downward, and this loop current will be the upward. In that case, both the directions are opposite. That's why its entry is minus 1. And if coming to the branch number 5, this entry and this entry, both the directions are same. That's why its entry is plus 1. Which we have branch number 2, 3, and 5. We have the branch number 2, 3, and 5. That is 2, 3, 5. In that mesh or in that tie set, that's why those entry will be plus or minus. And remaining entries, that is nothing but branch number 1, branch number 4, and branch number 6. These are not the part of this particular loop. That's why those entries will be 0. Similarly, if I'm coming to the tie set number 3, we will make only the entries of this tie set. What is the tie set? Branch number 1, branch number 3, and branch number 6 is the tie set. Is it right? Now, how is the entry for this branch number 1? This direction of the current and this assumed direction of the loop current both are the same. That's why its entry is plus 1. For the branch number 3, its both entries are again same. That's why both the directions are same. That's why its entry is again plus 1. For the branch number 6, again same is the case. And apart from this 1, 3, and 6, other branches are not connected in that particular loop, or not part of that loop, or not part of that particular tie set. That's why those entries will be 0. This is the way of preparation of the tie set matrix or fundamental tie set matrix, which is BF. So here in this case, we have prepared here the fundamental tie set matrix, which is the BF. If we have prepared the fundamental tie set matrix, now look at how is the next procedure. If I'm coming down, otherwise I will go to the procedure part. How is the procedure? Now look at, I'm discussing about the procedure. First point is draw the oriented graph. Second is select a tree, prepare a tie set, and prepare the tie set matrix. And next part is the prepare the ZB, that is branch impedance matrix. It is of order B into V, where B is the number of branches. Means we will prepare branch impedance matrix. Look at here. This is the branch impedance matrix. How is the structure of this branch impedance matrix? This is general structure. This is Z11. This is Z12. This is Z13. Is it right? This is Z14. Next is Z15. And finally it is Z16. Is it right? And here it will be Z11, Z21, 22, and so on, Z22, and so on. The rest of the matrix, something like this. But what is this Z11? Z11 is nothing but impedance of the first branch. This impedance. Z12 is impedance of the first and second branch, or common impedance of the first and second branch. There is no impedance common to the first and second branch. That's why its entry is 0. This is not the loop. It is a branch. It is about the branch. That's why only the diagonal elements will present in this ZB, that is branch impedance matrix. Other elements will be 0 in this particular case. Now look at here. The Z11 impedance of the first branch is 5. Impedance of the second branch is this again 5. Impedance of this third branch is the 10, because this is Z11, Z12, Z2, Z13, 14, 15, 16, Z21, 22, 23, 24, 25, 26. Here Z31, 32, 33. Means here 11, Z11, Z22, Z33, Z44, Z55, Z66. These entries we are making. This is Z33, which is 10 ohm. Then impedance of the fourth branch, again it is 10. Impedance of the fifth branch, again it is a 5. And impedance of the sixth branch, which is the again 5 ohm. This is not the YB. It is not the admittance matrix. It is the impedance matrix. For this particular given figure, we will prepare this matrix. Just we are copying the elements. This is the preparation of the impedance matrix. Is it right? If we know the branch impedance matrix, then we will prepare this ZT, which is tight-set impedance matrix. Tight-set impedance matrix using this equation. What is the equation? BF into ZB into BF transpose. BF into ZB into BF transpose. First, what I have done, I have taken this BF, that is fundamental tight-set matrix. Now look at the entries 110100. Here I have taken 110100. This is BF, that is nothing but branch or tight-set matrix. I have copied this tight-set matrix. Here I have taken this tight-set matrix here as it is. This is the tight-set matrix, which is nothing but this BF. ZB is the branch impedance matrix. Just I have copied this ZB. There is 5, 5, 10, 10, 5, 5. I have copied this. Now here in this particular case, this is ZB. 5, 5, 10, 10, 5, 5 is the ZB. And this is the transpose of this matrix. Is 110100, 110100. Then second row will be 01 minus 1010. This is 01 minus 1010. And finally 10 1001, 101001. This is the BF transpose. This is this matrix. This is the impedance matrix. This is ZB. And we are interested in the calculation of this value, which is nothing but the ZT, which is the tight-set impedance matrix. Is it right? If we are finding the multiplication of these two terms, these two matrices, we will get this matrix. How is the case? Look at this 5 into 1 is a 5 plus this 0 plus this multiplication 0 plus this multiplication 0 plus this multiplication 0 plus this multiplication 0. This is value is the 5. Then this row and second column. This is 5 into 0 is 0. This 5 is 0 into 0. 0 into 1 is 0. This 0 into minus 1 is 0. This 0 into minus 1 is 0 is 0. This 0 into 1 is 0. This 0 into this 0 is 0. This here that value is 0. Similarly, we are finding the multiplication of this row and this column. This 5 into 1 is a 5 plus 0 plus 0 plus the 0 plus this multiplication 0 plus this multiplication 0. This is next value is the 5. Means if we are finding the multiplication of this matrix with this, we can compare or we can check for this again. We can check for the row number 2. If I am taking the row number 2, this is row number 2 and this column. Now only check these elements, this element, because in this case all the elements are 0. It's 5 into 1 is a 5 plus 0 means it is 5. This into this. Check the second number of this column 1. This is 5 into 1, that will be the 5, remaining entries are 0. Then here check this second. This second is a 0. Because in this case remaining are 0, means this 5 into 0 is nothing but 0. Which in this way we will prepare this matrix. Multiplication of these two matrices. Then here again if we are finding the multiplication of these two matrices, in that case 5 into 1 is a 5 plus 5 into 1 is 5 plus 0 plus 1 into 10 will be 10 and then 0 and then 0. You see, if we are finding the multiplication of 5 plus 5, that is 10 plus this 10 will be the 20, is that multiplication. Then, what is the second? This row and this column. This 1 into 0 is 0, this 1 into 5 is a 5, this 0 into 10 is 0, means in all total addition is a 5. Then 1 into 0 is 0, 0 into 5 is a 5, again 0 into 0 is 0, means here this effective multiplication is this. There is 1 into this 5, which is nothing but this 5, and so on. If we are multiplying the same row and this column, this 5 into 1 is a 5 plus this 1 into 0 plus this 1 into 0, 0 into 10, this 1 into 0, this 0 into 0, this 0 into 5, that is again 5, and so on. In this way, we can find out the multiplication of these two matrices, and we can find out the value of ZT, which is nothing but tight-set impedance matrix, which is this. It's 20, 5, 5, 5, 20, minus 10, 5, minus 10 and 5. This is nothing but ZT, that is Tyset impedance matrix. This is Tyset impedance matrix. If we know the Tyset impedance matrix, in this case we can prepare the voltage source matrix. Look at, I will go back and I will discuss the procedure. How is the procedure? Procedure is something like this. Yes, what was the previous case? Prepare the Tyset impedance matrix ZT using this equation. We have prepared this ZT. Now we will prepare this, that is voltage source matrix, or prepare branch voltage source matrix. This is VS1, VS2, VS3, VS4 and so on. But how are the entries? Elements in the VS matrix are taken as a positive if branch current enters the positive terminal of the voltage source available in that branch. Means if it enters into the positive terminal, then that entry will be the plus, otherwise that entry will be minus 1. Now I am coming to this figure. Now look at how is this direction? This direction is upward. If I am taking this direction from here, where the current enters in the negative terminal. If current is entering into the negative terminal for this branch number 1, then its entry will be minus 50. For branch number 2, there is no source, that's why its entry is 0. For the branch number 3, there is no source, its entry is 0. For the branch number 4, there is no source. For the branch number 5, there is no source. For the branch number 6, there is no source, that's why these entries are 0. Now look at how this entry is a minus 1. If we have taken this current downward, in that particular case, this entry will be the plus, because in that case, this current will enter into the positive terminal of the battery. In that case, we will take that voltage as a positive, otherwise that voltage will be the negative. In this case, whatever is the random assumption of the direction of current, assume this direction randomly. And if this assumed direction is entering into the negative terminal of the battery, in that case, this entry will be the minus 1. This is the preparation of the voltage source matrix, which is VS. If we have prepared the VS, we will prepare the equilibrium equation. Otherwise, I will go back to the procedure. Look at how is the procedure. After the preparation of this VS, if we will prepare the VS, after this preparation of the VS, we will prepare this equation, ZT into IT, which is equal to minus BF into VS, and we are trying to find out the IT, which is nothing but Tyset currents, which is indirectly, it is nothing but the loop currents. We are interested in the calculation of the loop current, which is, in this case, it is known as the Tyset. I will come back to here. Prepare the equilibrium equation ZT into IT, which is equal to minus BF into VS. Now look at, if I'm coming back to the previous case, how is the first ZT? What is the ZT? ZT is this value, that is Tyset impedance matrix 20, 5, 5, 5, 20, minus 10, 5, minus 10 and 20. If I'm checking that 20, 5, 5 means I have taken that particular matrix here, which is nothing but the ZT. This is ZT. IT is the Tyset current or loop currents. We have the 3 loops, I1 is 3 loops, and first loop current is the IX, second loop current is IY, and third loop current is the IZ. These are the 3 loop currents. This is the Tyset matrix, a fundamental Tyset matrix. This is fundamental Tyset matrix. This is VS. Now look at it. This VS we have copied from the previous slide, which we have taken from this particular slide. Look at it. This is VS. I have taken that VS case. So here in this case, what is the unknown? Unknown is this IX, IY and IZ. IX, IY and IZ. If we are finding this multiplication on the right hand side, this row into this column, 1 into minus 50 plus 0 plus 0 plus 0 plus 0 plus 0, means that value is minus 50, which is here. The second row and the second column, in that case, the second row and the second column, how is the entry? The 0 into minus 50 is 0, then this is 0 into this 1 is 0, this into this 0 is 0, then 0, then 0, then 0, this value is 0. Finally, this value is 1 into this minus 50 is minus 50 plus this into this 0 plus this into this 0 plus this into this 0, then plus this into this 0, then this 1 into the 0 is 0. This its value is minus 15. This is minus 50, 0 and minus 50. If we are multiplying by this minus sign, this will be the plus 50, 0 and plus 50. This is the multiplication of these two matrices, df into ds. This multiplication is this much, that is 50, 0 and 50. If I am coming down again, what I have done? I have taken this value as it is. I have taken these values as it is. These values as it is. And this value. And we are able to find out its current using the calculator. We are able to find out its current using the calculator. If we are using the calculator and if we are finding these values of the currents, this first equation will be 20 into Ix plus 5 into Iy plus 5 into Iz, which is equal to 50. This is first equation. Then 5 into Ix plus 20 into Iy minus 10 into Iz, which is equal to 0. This is the second equation. Then 5 into Ix minus 10 into Iy. This is plus 20 into Iz, which is equal to plus 50. This is the third equation. And if we are solving those three equations, or if we are using the calculator for solving those equations, we will get the answers. First current Ix is 1.66, Iy is 0.83. And the value of its third current, which is nothing but Iz, and in that particular case, the Iz is found to be, which is 2.5 amperes. Is it right? In this case, or in this step, we have calculated the tie set current. This is the first tie set current. This is the second tie set current, and this is the third tie set current. Tie set current is nothing but which is current. The tie set current is this. This is the first tie set current, is nothing but first loop current. This is the second tie set current, which is the Iy, and this is the third tie set current, which is the Iz. Which we have calculated these loop currents. Ix, Iy, and Iz. These are the three tie set 1, tie set 2, and tie set 3. Which we have calculated these loop currents. And from these loop currents, we can find out this branch current 1, branch current 2, branch current 3, branch current 4, branch current 5, then branch current 6 by using some relation. Now I will discuss here which relation we are using. If we know these currents, if we are aware of this tie set currents or loop currents to be exact. If we know the loop currents, then we can find out the branch currents. We can find out the branch currents using the equation. This IB is equal to, what is the equation? This IB is equal to BF transpose into IT. This IB is equal to BF transpose into IT. This is transpose of the BF matrix, which is nothing but tie set matrix or fundamental tie set matrix. With this IB, this is BF transpose, which is transpose of the fundamental tie set matrix, and IT is nothing but tie sets currents or loop current. This is 1.6, this is 0.83, this is 2.5, which I have copied from this previous figure. This is 1.66, 0.83, and 2.5. Those values. Now look at here. This I1 equal to, I have tried to mention here, this I1 is equal to 1 into 1.66 is 1.66. The 0 into this 0.83 is 0. This 1 into 2.5 is this 2.5. And addition of this is the 4.16 amperes is the value of its first current, which is I1. Similarly, if we are finding the second branch current, this I2. This I2 is equal to multiplication of this row and this column. 1 into 1.66 plus 1 into 0.83. This is 0.83, this is 0.86. And this is 0 into 2.5, this is 0. And if we are working on this arithmetic operations, we will get its current, which is 2.53 amperes is the current in the branch number 2, which is I2. Similarly, if we are finding the branch in the third current or third branch, this multiplication of this matrix or this row into this row. 0 into 1.66 is 0. This minus 1 into 0.83 is minus 0.83. This 1 into 2.5 is, this is plus 2.5. If this is minus 0.83 plus 2.5, its value will be the 1.67 amperes is the value of the third current. Similarly, its fourth current I4 is this row into this column. 1 into 1.6 plus 0 plus 0 is this value 1.6 amperes. Is it right? Similarly, multiplication of this row and this column. This is 0 into 1.6 is 0. This 1 into 0.83 is 0.83. The 0 into 2.5 is 0. And this value is 0.83 amperes. And finally, if we are finding the branch current of the sixth branch, which is multiplication of this and this. Is 0 into 1.6 is 0, the 0 into 0.83 is 0, then 1 into 2.5 is 2.5, which is equal to 2.5 amperes. This is the calculation of the branch currents. Is it right? Now here we have calculated the branch currents. Initially we have calculated the loop currents. Is it right? These are the loop currents, which is nothing but the IT. And from IT we have calculated the IB. And if we know the IB, we can find out the branch voltages. The last step in this particular calculation is the calculation of the branch voltages. Calculation of the branch voltages using the following equation, and this equation is VB is equal to ZB into IB plus VS. This VB is a column matrix, V1, V2, V3, V4, V5, V6. ZB is the branch impedance matrix, which is this. IB is the branch current matrix, just which we have prepared in the last figure. This is 4.16, 2.13, 1.67, then 1.66, then 0.83, then 2.5. This is 2.5. Is it right? Means multiplication of these two plus or minus this value. Now look at how is the case, how I have done the calculation. This V1 is equal to 5 into 4.16. This is 5 into 4.16. Then this 0 into 2.3, this is 0. This 0 into 1.67, this 0. This 0 into 1.66 is this 0. This 0 into this 1.83 is this 0. This 0 into 2.5 is this 0. Plus this minus 50. Plus this minus 50. And if we are doing this calculation, its value is near about 20 point something. And minus 50 means its value is 29.2 volt is the value of the voltage across the first branch, that is V1. Voltage across the first branch V1 is this value. Similarly, if we are finding the voltage V2 across the second branch, this V2 is equal to 0 into 4.16 is 0. This 5 into 2.13 is this value. Then 0 into this value is 0. Then this 0 into this value is 0. Then 0 into this value is again 0. This 0 into this value is another 0. Plus this element, second element, which is again 0. It is multiplication of 5 into 2.13, which is nothing but 10.65 volt is the value of the voltage source, which is V2. Similar is the calculation for V3. This 0 plus 0 plus 10 into 1.65. 0, 0, 10 into 1.65. Then this is again 0. Then this is 0. This is 0. Means this is 0. This is 0, 0. Plus this third element, which is again 0, which is 16.5. Is it right? The calculation of the voltage across the fourth branch, which is V4, in this particular case, this is 0 plus 0 plus 0 plus 10. 0 plus 0 plus 0 plus 10 into 1.6 is this value. Plus 0 plus 0 means this is plus 0 plus 0, and finally this value is 0. In this particular case, this is the value of the V4, which is the voltage across the fourth branch. Similar is the case for V5, is multiplication of this into this, or plus or minus this value, which is plus 0 in this case. That will give the V5 as 4.15, and finally V6 is nothing but it is multiplication of this row and this column plus this value will be this last voltage, which is V6, which is 12.5. This is the way of calculation of the first point is nothing but tie-shaped current or loop currents, then calculation of the branch currents, and then the calculation of the branch voltages. That's it about this particular problem. Thank you.